you see in all options there is q by z. Here you see q by z in A, q by z in B, q by z in C, q by z in D. So first we write this group, I mean the elements of this group q by z. Here at the top q by z. The elements of this group is z. Z is the identity element, and thereafter 1 by 2 plus z, comma 1 by 3 plus z, 2 by 3 plus z, comma 1 by 4 plus z, and 2 by 4 plus z is equal to 1 by 2 plus z. That is already written. So the next will be 3 by 4 plus z, and so on. In this way you can write, and you observe that obviously q by z, the order of q by z is infinite. Okay, now we go for the options. See the first option. Here you have the first option. It says q by z contains a subgroup isomorphic to z plus, the set of integers. Okay, so you should remember that a subgroup isomorphic, two isomorphic subgroups contain same number of elements. Okay, and here you see this z plus, the set of integers, is an infinite group. I mean order of this group z plus is infinite. So since subgroup is isomorphic to, it is written there, it means that that subgroup should also be infinite. So we have to search for an infinite group in q by z, for an infinite subgroup in q by z. Okay, it is clear now. So see the subgroups of q by z. I write the first subgroup is z, and its order is 1, order 1, and the second subgroup, you can say first, second, not the other one, you can say the other subgroup will be z plus 1 by 2, and also its order is finite, that is 2 is finite. So in this way, if you go and you see the other subgroups, then you will notice that all the subgroups are finite. There is only one subgroup of q by z that is infinite, and that subgroup is q by z itself. Okay, so we arrived at a conclusion that, suppose option A is correct, this means that q by z should be isomorphic to z plus. Okay, so let us check it is true or not. Q by z is isomorphic to z plus. Okay, so you know q by z has a subgroup. I already written that. I again write the same. Suppose that subgroup is H, and you know this H containing Z and Z plus half is a subgroup of Q by Z. And if you have studied isomorphism, then you should know that its image, that is phi H, should also be of order 2. Should be of order 2 because this is an isomorphism, order 2. And also this phi H should be a subgroup of this Z plus 1. So now I have to search for a subgroup in Z plus of order 2. If you go to search, you will never find a subgroup of order 2 in Z plus. So our option A is false. Okay. If you don't understand, then you should study about isomorphism, the words, the special words which I told in this video so far. And then even then you don't understand, then see this video from the starting point. Okay. And you know, we have got option A as a the statement in option A as a false statement. And here you see in the question we have to choose the false statement. So we are done. There is no need to go for B, C and D. Our option A is to be marked in the examination because we have to choose the false statement, false option. But here you know you are not in the examination hall this time, so we should learn B, C, D, the remaining 3 options. That will be beneficial for you. Why those 3 options, I mean B, C and D, are true. Okay. Now we go for option B. In option B, it says there is exactly one group homomorphism from Q by Z to Q plus. So far, you see that in Q by Z, there is a subgroup of order 2. Okay. And homomorphism, you know, homomorphism means this time there is a homomorphism. Remember that. So this time order of H, order of phi H may not be equal, but order of phi H should divide order of H. I mean order of phi H sorry, one second. Order of H divided by order of phi H in case of homomorphism, not in isomorphism. In isomorphism, order of these two must be equal. For homomorphism, the order of H and order of phi H, if you divide, then you get a positive integer. Okay. It means that since order of H is 2, so here I erase this thing because this thing was for isomorphism. Okay. I erased a part of the screen because that was for isomorphism. Now we are in option B. In option B, it is homomorphism, and for that this relation should satisfy this relation. Sorry. This relation should satisfy. And you see order of H is 2. So order of phi h should be 1 or 2, but as I explained earlier that phi h is a subgroup of q plus. This time you see here q plus, and in q plus there is no subgroup of order 2. So the order of phi h will be 1. What does it mean? It means that all elements of H maps to the identity element in Q plus. And in the same way, here I have proved that all the elements of H, this subgroup H, maps to the identity element, and here H is a subgroup of order 2. If you take some other subgroup, say I take now some other subgroup, suppose this time I take H equals to Z 1 by 4 plus Z, comma 2 by 4 plus Z, comma 3 by 4 plus Z. Okay, so this group is cyclic. Also the order of this group is 4. Okay, so this time order of phi h should be an integer, positive integer. Okay, so what does it mean? It means that phi h, the order of phi h should maybe 1, 2, 4, but you know there is no subgroup. We already discussed that there is no subgroup in Q plus of order 2, and also there is no subgroup of order 4, no cyclic group of order 4 in Q plus. So it remains the only one option, that is 1. So this time as well, these four elements 2, 3, 4, these four elements map to the identity element in Q plus. And from here, and if you take some other subgroup of Q by Z, then in all cases you take common thing, then you will have that all the elements of Q by Z map to the identity element of Q plus. This means that there is only one homomorphism from Q by Z to Q plus. So our option B is true. Okay, it is true. So option B should not be marked in the examination because we have to choose the false one. We have already chosen. We are going to see the remaining options for the learning purpose only. Now we go for the for option C. Okay, so for that I have to erase this thing first to make a space. Okay, now I have sufficient space. Now C, option C. For C, it says that for all n belonging to n, it means that you have to take 1, you have to take 2, you have to take 3, all the values. You have to take all the values 4, 5, 6, 7, 8, 9, 10, everything. It says that there exists an element G in Q by Z whose order is G. The order of G is n. What does it mean? It means that suppose n equals to 1. So G will be Z, because Z is the identity element in Q by Z, so its order is 1. Okay, so we have a natural number 1 and also an element in Q by Z whose order is 1. In the same way, now take n equals to 2. N equals to 2. Okay, now this time take this element. I show you in green this element. Okay, if you are taking that element, then what happens? I show you that element is 1 by 2 plus Z, and you take this element 2 times 1 by 2 plus Z, and you are adding, because addition is the group operation here. So this will be 1 plus Z, and you know 1 plus Z is Z, the identity element. It means that the order of 1 by 2 plus Z is 2. So there is a natural number 2, and also there is an element in Q by Z of order 2. In the same way, you can find an element in Q by Z of order 3, order 4, order 5, order 6, and so on. So our option C is also correct. Okay, so true, T for true. Now we go for option D. It remains the last option. In option D, it says, what does it say? It says Q by Z is not a cyclic group. This statement is also true. Okay, because you know there are many characteristic properties of cyclic groups. Among those properties, there is a property that every cyclic group has a generator. Every cyclic group has an element which can generate the entire cyclic group. That means all elements of that cyclic group. But here in Q by Z that I have written at the top, there is no element which can generate the whole elements of this Q by Z group. For example, I assume that 1 by 3 plus Z is a generator. Okay, then generator means you can add 1 by 3 plus Z as many times as you wish. I add 3 times. Here you see, okay, 2 times. I first add 2 times, then this will give us 2 by 3 plus Z. Oh, so you will be very happy that this 1 by 3 plus Z giving us a different element of Q by Z, 2 by 3 plus Z. You see here, 2 by 3 plus Z and 1 by 3 plus Z, both are different. So here we say that 1 by 3 plus Z is generating 2 by 3 plus Z, but 1 by 3 plus Z is not generating the all elements of Q by Z. What I think you understand this thing, but I will speak more about this. Here I have assumed that 1 by 3 plus Z is a generator. It means that 1 by 3 plus Z should also generate this 1 by 7 plus Z. But you know, whatever times you add 1 by 3 plus Z plus 1 by 3 plus Z plus 1 by 3 plus Z, it will never give you this element. So it means 1 by 3 plus Z is not a generator of Q by Z. And in the same way, if you are taking some other element, suppose you are taking for the second time 1 by 7 plus z, and you assume that it is a generator. So if you add 1 by 7 plus z, 1 by plus 1 by 7 plus z plus 1 by 7 plus z, then you will never get 1 by 43 plus z. 1 by 43 plus z is an element of q by z, but 1 by 7 plus z will never generate 1 by 43 plus z. 1 by 43 plus z is, for example, it also 1 by 7 plus z, it will also not generate 1 by 37 plus z, whatever time you add. Okay, so what does it mean? It means that q by z has no element which can act as a generator. It means that q by z is not a cyclic group. So option D is true. So okay, we have gone for all the options. So I again repeat that if you are in the examination hall, you have to choose the false one. As soon as you get the false statement, the false option, you should mark. You should not go for the remaining options. It is wise, because time is a important factor in the examination hall. But here we are for learning purpose, so we checked the remaining options as well. Okay, so this question